implementations. Here the object is said to be an instance of a class. Who will create the object? Class will create the object. So object is said to be an instance of a class. So the process of instantiating a class allocates storage for the object's internal data. So why are you creating the process? You are going to create the process. That means you are instantiating a class. So once you instantiate the class, what actually the class does? The class will create object. Creating an object means it will allocate the memory space for the object's internal data. Object contains the data. The data is going to be stored. Who will give the memory space? Who will allocate? Class will allocate the memory space for the object's internal data. So who is instantiator here? Class is an instantiator. Who is instantiating here? Object is an instantiatee. Are you following? The object is said to be an instance of a class because class will create the object, whereas the process of instantiating a class allocates storage for the object's internal data. So you are instantiating the class, therefore class will provide the memory space for the object's internal data. So instantiator is a class, instantiatee is an object. Next we have new classes can be defined in terms of existing classes using class interface. One second. What is that? New classes can be defined in terms of existing classes. That's what. Using the existing classes, I can create new classes. How is that done? Using class inheritance. Inheritance is nothing but interface. That means from the parent class, what I am going to do, I will create subclass. So that is called class inheritance. So next step we have explained in detail about that. Subclass inherits from parent class. That's what. Subclass is a part of the parent class. Whereas parent class is nothing but a superclass. Okay, now from the superclass we have created new classes called subclasses. That you can see in the diagram. I have a parent class. Now I will assign the job to the subclass, specifying the operation to be performed, and I have the subclass here. Subclass means you can go for n number of stages. Object's internal data is made up of instance variables and associates the operations with these data. So what actually the object's internal data contains? Data is made up of instance variables. What is variable? Variable means it is a type, data type it is. What type of data you are performing the operation, whether binary data, decimal data, whatever. Say for example, I will go for binary data, and what are the data values you can go for? You can go for either 0 or 1 and associate the operations with these data. So what are the operation you can perform with respect to binary data? You can perform OR operation, AND operation. So based on that, if you go for an OR operation, then if the input is 0 and 1, your output is 1. Something like that. So what actually the object's internal data contains? It is made up of instance variables. Instance variable is nothing but the data type, whether the binary or decimal, whatever. The name of the data type it is. And associates the operations with these data. What type of operation you are performing? Whether logical or and any other operation. So data means the value of the data type, whether it is 0 or 1. Next we have return types and instant variable types. Instant variable types in the data type name, just whatever we have discussed. Return types means the value of the data. Okay, either 0 or 1 in case of binary. So these are optional since we are not using statically typed implementation language. So last class I explained about dynamic binding and polymorphism, correct? We usually go for dynamic binding. What is that dynamic binding? It will determine the object during the runtime. If you go for static binding, it will determine the object type which time during compile time. So here we are going for dynamic, though therefore it's not necessary to define or declare the return types and instant variable types during compile time. So instead what we will do, we can give these values, the name of the variable and the return type and the value of these variable during the runtime itself. Since our design pattern is a type of dynamic, we can declare during the runtime. So what actually object contains? Object internal data is made up of instant variables. Instant variable is nothing but that variable data type, and the operations with these data means which are the operation to be performed you are going to write, and these data is nothing but the return type, the value. Okay. So here in the diagram, we have class name, the name of the class, whether it is abstract class or concrete class, whatever, and what are the operations you are going to perform on the object to be defined, and type of the operation, whether logical or operation and operation, whatever. You have to specify here. Then you have to specify the instance variable name here. That's what the name of the binary data type, whatever. Then type instant variable. That means return type here. Return type means the value of the data and what is abstract class and what is concrete class. Here abstract class it defines common interface for its subclass. Only the definition is done. Only what type of means it will you are interfacing, you are inheriting the parent class to subclass. So just it defines what type of interface you are going to do. Next we have it declares the operations but does not implement it. That's what it is just defined. The implementation part is taken care by the next one, the concrete class. In the very second class, I was discussing about abstract class. No, abstract class includes the that means it is a type of concrete class without implementation. Concrete class means with implementation. Abstract class means without implementation. Abstract class will just define an interface for its subclasses. That's what. From the parent class, what is that interface I am going to provide for subclass? Its definition is done by the abstract class. And it also declares what type of operations to be done, but it will not give any implementation part. When I go for concrete classes, here classes that are not abstract are called concrete classes. That means here only definition I am not going to define here. Definition is already done. Declaration is done. Now I am going to implement. You are going to perform the operation in the concrete class. So what actually the concrete class does? A concrete class implement creation methods of the abstract factory. So here the definition is done. The abstract class will define with the help of the abstract factory. So for these defined operations, I am going to implement the code. I will create the code by using which class? By using concrete class. So what are the two different classes we discussed now? Abstract class and the concrete class. In the abstract class, just definition is done. What is that interface I am going to do? What is the name of the parent class? What are the names of the subclass? Just I will define. This is the interface to be done. That's it. And I will declare the operation. These are the operations to be performed. Parent class is going to assign the jobs for each of these subclasses. And just a definition here. No implementation part is included in the abstract class. Whereas when I come to concrete class, here it is not same as abstract. It is the classes which are not abstract is known as concrete class. Here definition is not done. Instead, I am going to implementation part. So whatever I have already defined in the abstraction, that I am going to create, that I am going to implement. That is called concrete classes. Next we have override and operation. How to override? How once into one I have defined the name of the classes, I have defined the operations to be done, and I am going to write the code. Then now how these subclasses will run all whatever we have assigned now, parent class is assigned the job to subclass. How this subclass will carry that? That is called as override and operation. So what actually here to be discussed here, the first point, subclasses override an operation defined by its parent class. That's what parent class has assigned the job to subclass. Now it will perform the operation assigned. Now subclasses redefine the behaviors of their parent classes. That's what. Subclass is a part of a parent class. It will do the job a part of the parent class. Is that clear? What are subclasses? Subclasses are interface, are inherited from the parent class. So parent class will assign the operation to the subclasses. Whatever we have assigned, that is taken care. It will carry the operation. It will do the job specified by the parent class. Subclass, that means it defines, redefines. I have already defined in the parent class. Now it will redefine the behaviors of their parent class. Whatever assigned, it will be done. It will carry the operation specified by the parent class. That is called overriding an operation.